Hello, everyone, and welcome to our webinar on making migration to OpenShift 4 easy with Kasten K10. This is Singh Garewal from Kasten Marketing, and I have with me Gaurav Rishi, our head of products, who will help manage audience questions. During the session, the audience will be on mute for sound quality, and I encourage all of you to ask your questions using the Q&A panel, and we'll answer those both during and at the end of the session. And now I'm delighted to introduce our main speaker, Michael Corsi from SOPRASTERIA, who will share his experience with you. Over to you, Michael.
Thank you. We recently made like a big experience, like a journey experience about migrating from OpenShift 3 to OpenShift 4 with a tool because we really need it, and it was Kasten. And yes, I'm very happy to speak about that and to present to you that right now. So to speak about me, I have 20 years in IT, which give me experience on old stack and on the new ones as well. And replatforming, refactoring, modernizing big legacy application or information system is what I love to do, because it involves different stack built at different time with different technology, and it's very challenging. So in our company, we build a very big development cluster open to every employee of SOPRASTERIA. And anyone that wanted to test something, to build something, could try. They already have the right to create project and to try things, but we also welcome some very big development team of 20 until 30 persons to develop. So for those people, the OpenShift cluster is like an environment of development, but a very important one. It's like a production. After 2 years, without advertising too much inside the company, we get something 120 serious projects inside the cluster with about 700 developers working on it regularly, very regularly. And all that managed by about 2 administrators. And for that, it was very important for us to move. And to speak about SOPRASTERIA, the company I work for, it's one of the top 5 European players in IT service industry. We are operating in 25 countries, mainly in Europe, but also in India. We're working on many fields like aerospace, insurance, defense, government, energy, transport, and so on. We have something like 46,000 collaborators. We make a sales in 2019 of 4.4 billion euro. And I must say that my company is like an infinite playground. And of course, we are in, so don't hesitate. So now it's time for me to introduce James from Red Hat and Tom from Kasten. So guys, your turn.
Hey, thanks, Michael. James Labaki, Director of Product Management in our Cloud Platforms business at Red Hat. Responsible for solutions that help our customers actually get to both adopting OpenShift as well as getting their workloads to the platform. Tom?
And my name is Tom Manville. I'm an engineering lead at Kasten, where our goal is to simplify data management in Kubernetes. I was fortunate to work with Michael and his team on this massive migration, and I'm excited for him to share with you all the interesting challenges we hit along the way. And so back to you, James.
Yeah, so before we dive in, I just want to take a quick minute just to level set what OpenShift 4 is. So really what it is a smarter Kubernetes platform. So building on the foundation of OpenShift 3 and the acquisition of CoreOS, what we've done is we've actually delivered just a platform that is far easier to deploy, far easier to operate, and much better from a developer experience standpoint as well. So we provide automated full stack installations as well as one-click updates. So whether that's security updates or updates actually to the operating system, because of this linkage we now have between Kubernetes and the operating system. This also helps us scale at a node level for on demand. And as you'd expect, this works across all 4 footprints, whether it's in your data center, virtualized, private cloud, all the way to public cloud as well. Next slide, Michael, and I'll just touch on a few salient highlights of OpenShift 4, and then we want to focus on kind of the journey there as the main story here. So a couple of quick things that you should know. Operators. So operators are really a way of packaging, deploying, and managing Kubernetes native applications. So this takes a big burden off the user, and both from an operations standpoint and a dev standpoint, because now they don't have to worry anymore about how they manage the life cycle of those. If they adopt things in this operator framework, it'll actually take care of updates and many other aspects of lifecycle management. So that's new in OpenShift 4. We also introduced a service mesh. So this allows your applications to have connectivity to one another. But we also have tracing and monitoring tools, including Istio, Kiali, and Jaeger, to help you with troubleshooting and tracing network connectivity for your applications. There's also been a big focus on serverless, so building on Knative. We're actually now supporting a number of data sources, including Azure Functions, OpenWhisk, CamelK, and others. And then finally, code-ready workspaces, and really I would say the developer experience at large. That includes code-ready workspaces, which is like a well-integrated experience of Eclipse Che that allows developers to develop and deploy their applications on OpenShift seamlessly. But then it also includes plugins from VS Code, Azure DevOps, Eclipse IDE, and IntelliJ JetBrains to allow you to plug your specific IDE into this. And we've also introduced this advanced CLI called ODO that could give you a really powerful developer experience on this. So I think just a wealth, this is just scratches the surface of everything that is in OpenShift 4. And I hope this gives you a good overview. And with that, I will pass it over to Tom to talk about a little bit more about the K10 platform.
Thank you, James. So I wanted to give a brief introduction into Kasten's flagship product, K10, which helped SOPRASTERIA enable this migration. K10 is focused on data protection for Kubernetes, which includes a few key use cases: backup and recovery of Kubernetes applications as well as their data mobility, including migrations. This means backing up in one environment and restoring in another, with transformations along the way to handle differences between the 2 environments. Finally, disaster recovery, meaning we can bring back your applications after any type of disaster. K10 is designed for the enterprise, which was important here because of the complexity and scale of this migration. And so during this webinar, we're going to highlight how K10 managed to simplify and automate away some of the key challenges in this massive effort. So with that, I'll hand off to Michael to get into all the interesting details of migration.
Okay, thank you. So this is going to be the story of our Big Bang project journey. So first, one thing that I really need to highlight is what was the outcome of migrating to OpenShift 4? Why did we decide to make this move? The first reason was probably reducing the complexity in the maintenance and on the scale out. The cluster is much easier to maintain and to grow because a big bunch of the operation are now completely automated through the operators. And everything is nearly done through a comprehensive UI, a comprehensive and friendly UI. So just to give you some concrete example, adding nodes on the cluster before was taking something like half a day. Now it's just a matter of clicking on a button, so it's about 4 minutes. Renew the certificate with all the problem we could have. It could be sometime half a day because we had many problems. And now it's completely automated. We completely get rid of this annoyance. Upgrading to a newer version, that was the operation that every cluster admin fear when I have to upgrade my version of OpenShift. Now it's really secure and safe. It's really easy to upgrade to a newer version. We had some other outcome, like reducing the AWS infrastructure cost, because we must understand with OpenShift, everything is operated through the operator, but the operator is directly operating with the AWS API, or if you are installed on another hyperscaler, like, I don't know, OpenStack or Azure, everything is speaking directly to the cloud provider. So we get all the knowledge and the experience of the Red Hat engineer, and of course, we optimize the choice. We also, because we reduce the complexity, we were also able to outsource the operational team. And we use this opportunity to train a small but dedicated team in India, 2 persons, that learn a lot about the projects they will have to support. And another thing which was very useful is the fact that we had a lot less work on maintaining and operating the cluster, so we could give much more time to the end user, and that has really accelerated the adoption of the PaaS inside our company. We also have more security and more support from the editor because we are now easy following the last version. So we have all the security patch, and it's easy to get support because we are always on the edge version. And of course, the ability to use recent features of Kubernetes, because now OpenShift 4 is really following closely the version of Kubernetes, the last version of Kubernetes. So we get the ability to use the last features of Kubernetes. And another thing, which is extremely important, and I must really speak about that, is the freedom from the cloud provider. Because this experience gives us the experience of moving from a cloud provider to another one. It's a big freedom experience. It's not that we are not happy with AWS. We are quite happy with AWS actually. But we have now the ability to change and to try something else. And actually, sometimes we do. So we thought at the first place that migrating was like a glorified recovery, a disaster recovery. And actually it turned out that that was not the case. It's not just a disaster recovery. We had some few things that make a real difference. First, we are not working with the same version of the container platform. We moved from OpenShift 3 to OpenShift 4. So from a developer point of view, it does not make any real difference. The new UI was really well accepted by the developer, and the CLI was behaving the same way, but some API were not exporting well, especially the image stream tag API. We had also some surprise on the Red Hat base image, and I won't list all of them, but another aspect is that we were using an external Ceph cluster, and on OpenShift 4 is not supported anymore. We also changed the container runtime. We moved from Docker to Cryo, and here we had some issues about the build config. Not that much, but enough to be annoyed. We changed also the way we authenticate the user. We moved from user federation to OpenID with Azure ID, and that make a difference. This is not the fault of OpenShift 4, of course, but that was one of the migration aspect. And comes here the very difficult things that actually, because it's a dev cluster, the developer never work on their backup process. So we didn't have the experience of backing up and restoring, and that lead us to some very complicated things. So I'm going to speak about that later. And another aspect that was very difficult was the image resolution. The internal registry could not be reused as in, and many of our workload were relying on that. So I'm going to discuss that a bit later, a bit more in detail. But that was part of the problem. Sorry. So this picture is saying that our client, the dog, is finding the temperature of his coffee fine, even if the temperature of the room may not be fine. It's actually burning. So all that to say that you can test and validate some aspect of an application, but if you don't know it, at least a bit functionally, it does not mean that the application is working very well. So you may see that the pod is running, but inside it's burning. And that was one of the aspects of this. We had only 2 OpenShift administrators for 700 active developers. So it was very hard for us as administrator to validate that the projects we migrate were working fine. And to add to the complexity, we had some very, very different stack. We work with COBOL, Golang, PHP, Java, JE, Python, Node.js, and many, many kind of database. Actually, we accept anything, so we support anything. So it make the validation more complex. As I explained, most of the project never validate their backup strategy. And sometimes we saw some teams that were just doing manual change inside their container once they were deployed. And that was necessary to have them working properly. So that's extremely hard for us as administrator to capture that. And in some case, we had to deal with secret management. Sometimes we miss some image pull secret, or sometimes the image pull secret was completely expired, but because the image was already on the nodes, we never see that. And because it's a dev cluster, we have many times pods who are just not working. They are in a crash, look back off constantly, and that's fine. That's fine because it's a dev cluster. But in this case, how do you make the difference of this pod could be in a crash look back off and this one should not? And that was kind of complicated. We had another challenge, which was the volumes. First, we moved from, we had the chance to stay on the same cloud provider, but we changed the safe system from WorkSafe, and we work with a lot of projects. So we had something like 170 applications, 170 namespace actually, for like a big cluster. 54 nodes was a big cluster for us. And just to give you some figures, we had to migrate something like 2,126 pods, a lot of secrets, 300. And I'm not going to spell all the figures, but the volumes was really an issue because we had to do that in just one weekend, because we made the choice of the big bang migration. And because it's a big bang migration, you have to do it in a very short time. The next challenge we had to face was the image resolution challenge. If you are recovering, all you have to do is to restart the OpenShift registry on the backend storage you use on the former cluster, and you're fine. In our case, it was a S3 backend storage. But this registry of OpenShift 3 just did not work on OpenShift 4 for different reasons that I won't explain here because that would be too long. But mainly, that was because this OpenShift registry did not find dependency inside the OpenShift 4 cluster. So we couldn't just reuse the OpenShift 3 registry. So one simple and naive solution would be to copy the 11,400 image we had on the old registry inside the new ones. But doing that in just a weekend, it's likely to not work, to not fit the time frame. It really looks inefficient because you already have a S3. So why would you do all this network move? And besides moving an image to a registry to another one, could be something complicated. You have to handle the error. Sometimes the pull and the push just fail and you have to restart them. So that was not so easy. Oh, sorry. So at the end, we finally used the backend storage. We had the S3, but we use a registry V2, a classical registry V2 that can be used only internally. But this challenge took us some time. That was surprisingly a difficult thing to do. We had also another challenge. We wanted to be absolutely non-disruptive. That was absolutely needed because people are working on the cluster and they're spending time, and the time they lose is the money we lose. So the goal was to make all the tests the less disruptive possibly. So we had to minimize the impact of the backup and migrate on the running up. So we had to test a lot, which means doing backup and migration, but still there's people working on it and we must annoy them the minimum. And another thing was to find the right person for every project to make sure that the preview we created on the new cluster could be validated properly. So this non-disruptive challenge was not easy to keep because in some case we had some issue. We just stopped some project from working, and gradually we found the right way to do that, especially with the help of Kasten. But that was a challenge. That was a real one. So now it's time to explain what Kasten bring inside this challenge and in our process. So to see the migration from a 50,000 foot view, Kasten is not seeing the backup of an application as just a snapshot of your data, but it's the snapshot of your data and all the configuration of your application in the same time. I mean, all the Kubernetes resources inside the namespace. And this constitutes an atomic unit, and that Kasten call a restore point. So what Kasten call a restore point is the whole, the data plus the configuration of the application. And migrating is not just a copy and paste. You have to deal with difference between infrastructure, and Kasten handle that for you. Often you need to operate transformation when you're doing the migration, especially one obvious transformation that you often need to do is a DNS transformation because you need to change the domain of your application. And with Kasten, you can include that in the process of migration. So to look about all that more closely, what's a migration with Kasten? Basically, you start from a namespace. Then you launch a backup operation, a backup action. Then the backup action is going to create a restore point, which means data plus configuration. And then you launch an export action, which is going to create an exported restore point. Basically, it's going to push everything on the S3, or at least all the information needed for the restoration. And all that, you do that in what we call a backup policy, and you can do it weekly, daily, hourly if you want, if you need. Then you create an import policy on the destination cluster. And here you start from an import action. The import action is creating a restore point. The restore point, from the restore point, you launch a restore action, and the restore action is recreating the namespace with the data and the configuration, and you're done. And it's the combination of the backup policy and the import policy that make a continuous migration possible. In the middle of that, you can introduce blueprint. What's blueprint? Blueprint, basically, it's a way to orchestrate your backup. Often, you have to prepare your workload to be backup. For instance, imagine that you're working with a MongoDB. You need to flush everything on the file system before doing the backup. So you can use a blueprint for that. And most of the time, you need to reuse these blueprints all around your different namespace. So blueprint is something that you can share between namespace. You can also use transform when you are restoring the application because you often need to make some change on the destination cluster. So here you can do blueprint, of course, but you can also add some direct change of the API. So Kasten is not storage opinionated, and it's not a storage system actually. To make sure that everybody understands that, Kasten is not proposing a new storage class. Kasten is make the maximum to support all the possible storage system. So you have two ways to do backup with Kasten. The first way is doing a portable or a non-portable backup. The portable backup means that you extract the data and you extract everything and then you send them to S3 or to a repository, an external repository. But the non-portable backup, you only copy the reference. So it's particularly useful when, like in our case, you are working on AWS and you are doing some EBS snapshot. Then you don't want to move all the snapshot on the S3 and then to move it back. You just reuse the reference to the snapshot to recreate the volume. So it makes your backup much more quick, much more efficient. And it's really cheap on the network side because you don't have to put everything outside of your cluster. And that was really useful for us because we had both. We had safe storage, we had safe volume that was portable. We had to extract all the data and to be able to reuse them somewhere else. And we had EBS. So we had both, and Kasten is able to handle both. Okay. So to give you some little figures, with Kasten, we were able to export and import some batch of 10 to 15 projects with all the data in less than 30 minutes. So that was enough for us to make all the migration during the weekend. Then, as I explained you before, we didn't have any uniform backup strategy. And actually, most of the teams just didn't have a backup strategy at all. If there was intensive workload on the database, the snapshot you do may not be crash consistent or even application consistent. So to make things clear, crash consistence means that you didn't flush all the IO operation to the file system. And that was really the case with Safe. With Safe, we had very often some snapshots that were absolutely not crash consistent. And we realized that when we restore them. And application consistent means that actually you flush all the transaction of your database inside IO operation. So crash consistence and application consistence are two very hot topics when you're doing backup. And of course, what you want ultimately is application consistency. And we had many MongoDB, Zookeeper, Kafka, Postgres, and a lot of different kind of backend that were not just able to restart. We restored them on the cluster. And when we tried to restart them, it just didn't work. We had some errors and it was not restarting. So with Kasten, we were able to create a blueprint that I call the ultimate blueprint. And what does it do? It just stops all the workload on the namespace, just stop them. Do the backup. and restart them. And when you restore in this situation, when we restored on this situation, we were able to nearly restart everything. Then we get rid of all these issues. But the consequence is that you stop your workload for a little while, at least the time of the snapshot. So one good thing that Kasten do is it stop all your workload because of the blueprint you choose. Then it do a snapshot, and the snapshot is quite quick. And then you restart your workload. So that was the solution we found because we had too many projects, too many different kind of workload, and was not just possible to find an appropriate workload. But in a regular situation, you would say, for MongoDB, I would use this blueprint. For MySQL, I would use this one, and use a blueprint that doesn't stop your application. But in our case, that was not possible. There was too many. So we decided to do that. And actually, it worked. Nearly no teams noticed that we stopped their workload. Most of the time, the things were quick enough to be not noticeable. So on this, we solve a lot of issues during the migration. So now I'm just going to show you now how a blueprint is looking, especially our blueprint, our ultimate blueprint. So hey, as Michael, you can see,
Michael, I had a quick question on that. So if you were to use the application-specific blueprints, like the MongoDB blueprint, for example, would it change how long the downtime would have been for the app?
I really do think so, yes, because doing flushing all the transaction inside the file system is not that long, and you don't have to stop your workload. You don't have to stop. And because we are in a situation of ignorance, we stop everything. So stopping everything is taking time. And because you have to stop everything, and then you have to restart everything. So just doing a blueprint for the MongoDB would just do a flush from the MongoDB, then do the backup, and unset the freeze, and that's it. We're done. So yes, if we were using a specific blueprint, that would be much quicker. Yes, for sure.
Thank you.
So this is the ultimate blueprint we use. As you can see, it's a Kubernetes object actually, and we call it scale hooks. So you can see from the different line, especially the line 12 to 14, that actually we take any object and we just scale them to 0. Then on line 15, you can see that the backup post hook, so the things that is activated after the backup, we just scale them back to the value they were. And we store this value in their annotation. So that was our ultimate blueprint for restoring for making the backup and restoring the things. You often have also to filter what you really want to get in your snapshot. So for instance, in the source cluster, for historical reason, we were using a vertical pod autoscaler, and we did that because we wanted to help the pupil to know exactly what their pod were consuming to make the right choice on their requests and limit and so on. So we use a lot of vertical pod autoscaler, and then we didn't use it anymore. And we noticed that when we were moving the workload to the new cluster, we had some errors because the vertical pod autoscaler was not an object none on the destination cluster, and things were just not working anymore. So because of that, we were able to use the filter. And in this filter, you can choose the API, the group of API, or you can even choose a name of the object that you don't want to embed in your snapshot. And that's not all. You also often need to transform your API once you install it on the new cluster. For instance, in our case, we had to rename some secrets because we wanted to keep the information that this secret was coming from the old cluster. So what we did, if the secret has the name default, we decide to rename it OCP3 default. And we did that for every project. So this way we were able to do some operation that I won't describe here, but that was very useful. Another reason could be that you just want to mutate an API. For instance, when you try to install an image stream image, it just doesn't work in the destination cluster. So we change it for an image stream tag, and beside we change some value inside this API object, and that worked. So there is many use cases where you need to transform, because on the destination cluster where you're going, you have to take into account the specificity of the cluster. So that was extremely useful. So the last aspect about Kasten is Kasten is giving you a very nice UI, which is really well designed, reactive. You see everything inside, but for very large migration, you have to automate that. You really need to automate, and you need to test and to retest and test again. And for that, you create migration pipeline. And because of the volumes, we also need to make some batch. So we couldn't migrate everything in a straw. It was too much. 170 projects was too long. And we needed to validate batch of projects. So when you're doing that, UE is completely inefficient. But hopefully with Kasten, you have some CRD, base Kubernetes API, all the things that I show you, the backup action, the restore action, the export action, and all that is actually a Kubernetes object. So we were able to make, to construct, to build some bash script that were doing all this pipeline and to replay them constantly. And that was absolutely needed to succeed. And if you have a big migration, our recommendations is test your migration pipeline until you get it right. Then you'll be able to scale. Automation is something that you can't avoid when you are just doing very big migration like we did. And of course, you need a migration tool that is able to handle that exposing this. So now we may speak of Kasten in another scenario. Use it like not only for mobility migration, but just for protecting data. So here we have a usage on a dev cluster which may be a bit different from a classical cluster. On a classical cluster, what you just want to do is protect your data. By the way, I didn't speak about something, is why do we decide as a group to make so many stateful pods? Because some people were saying me, but why are you not using an external database? Why are you not using, for instance, RDS of AWS? RDS is great, and especially great when you are running on production. But we had something like 400 stateful pods. And if you see the cost of one RDS Postgres database, for instance, a reasonable one, it's at least 200 € per month. So just try to imagine how much it would cost if we were using external database for that. And if we really wanted to give autonomy to our teams, we couldn't create a bottleneck saying, okay, if you want a database, you have to go to the admin and ask for a new database. That won't work. So we decide to go to the solution of run your database on the Kubernetes. And actually it worked very well. And for a dev cluster, it's extremely efficient because now the developer, as soon as they need them, they can create their database as they want. There is no blockage. So the different usage we have with Kasten on the dev cluster is just doing a backup before a major change. But it's now something very easy. We build like a backup as a service for the developers. So they just go to the UI and they click and they do the backup. Another very useful thing is just duplicate the test environment to work on different tasks. You often have, you often find yourself in the situation where you have many test teams and they can't work on the same application because they are interfering with each other. So what's cool with Kasten is very easy to duplicate your namespace with all your data. So you duplicate them and then you put a different team on each namespace. So then you can parallelize the workload. And another very useful thing is to import a production snapshot, which means data plus configuration, inside your development cluster. And then you can troubleshoot. And it's much easier to troubleshoot in this situation because you really have the situation of your customer, of your production actually. So that's mainly the usage for dev cluster. So Kasten was really oriented data protection and mobility for Kubernetes and specifically for Kubernetes. So Kasten has a big knowledge of Kubernetes when it comes to backup and restore and mobility. When you have experience on backup and mobility with Kubernetes, you quickly find out that your cheap solution, and because we tried some cheap solutions, are not scaling at all. And you have no chance to meet real enterprise requirements. So if you think of what should be the right solution that could support exotic workload as regular database, then you find out that doing that properly, you need a product for that. And because you need a product for that, instead of developing yourself your product, we finally found ourselves saying, okay, we'd better use a professional product for that. And it supports a lot of storage systems, a lot of cloud providers, and it has the capacity to be multi-tenant, which means that we can expose it like a service for our user. And that makes the backup and migration as a service possible and easy now. So to conclude to this presentation, what I can say is that anyway, this migration was not going to be an easy migration. That was going to be a hard job, but Kasten really make things much easier for us. And I must say thank you, by the way. So yes, that's about all. And now, if you have questions, I'll be extremely happy to answer.
Hey, Michael. Thank you. This is Gaurav here. I think while you were speaking, and thank you for doing that along with James and Tom, we do see a string of questions that came up. So I think definitely your talk has been interesting and people have some follow-ups. So maybe what I'll do is I'll, I'm not sure I'll get a chance to go through all of them today, but I'll try and get the ones, as many as I can. And I'll just suggest that maybe you can answer some and, James and Tom, some might be more relevant to you. So feel free to add, it's more free-flowing and we can also follow up after email. So I think maybe the first one for you, Michael, and maybe James, you can add. I think the question was around OpenShift 4. That in your context, Michael, what were some of the compelling reasons that you decided to move to OpenShift 4? And I know, James, you had outlined some of the benefits, but maybe if you want to add more color.
Yes. Honestly, from our point of view, the main reason to move to OpenShift 4 was the reduction of the complexity on the management of the platform. And yes, that was probably the main reason, because when now you have some, most all the cloud providers are today giving their Kubernetes as a service solution. But the downside of that is that you have to manage a lot yourself as well. And it's not something that's really portable from one cloud provider to another one. So OpenShift was a good solution, but we still had this administration issue with OpenShift 3. And OpenShift 4 really solved the problem, because when you are working with OpenShift 4, you directly deal with the cloud provider API. And that solved a lot of problem. And yes, that was probably the main motivation. But I give some other motivation as well, like being on the most recent Kubernetes solution. The operator aspect is also, we start to enjoy it right now. We just start with that. So that's something recent, but we see the benefits, especially when you need to build a complicated database. So I won't take all the speech, and maybe James.
No, I think.
Yes.
Yeah, no, I think I couldn't have said it better than Michael. I guess I would just add, I think taking it from where you were managing multiple layers and having to worry about them, to taking it to, the infrastructure is basically managed via OpenShift now, and that kind of mindset switch, and allowing more fluid updates and security updates with less human interaction and more automation is definitely something we're seeing across our customer base. They're really, I think, seeing the benefit of that.
All right, great. Okay, so just sticking to the migration theme for a second, I think there was a question which is like, were you migrating the applications one at a time, or were they done in batches? So maybe, Michael, you might want to add a little bit more color on that one.
I didn't really get the question.
I think the question the person was trying to understand was, you had more than 170 applications that you talked about. So while it was a big bang migration, of course, there was a huge amount of scale required. So how are you logically grouping or batching these applications as you went through that, that big bang? Was it done?
Right. Okay. It was essentially for cost reason, because when you are maintaining, when you're doing that, which would be probably the most comfortable situation, where you just move a batch of application 1 week, and the next week you move another 10, and so on. That look cool, but if you just take the figures, imagine that you move 10 applications per week, the thing is going to last something like 17 weeks. And during these 17 weeks, you have to maintain 2 clusters. So to pay a lot of infrastructure, double, and you pay the license, double as well. So the idea in the big bang migration was reducing the cost, mainly reducing the cost, because you just move from one cluster to another one, and something like 3 or 4 days after the migration, we just shut down the whole cluster. And that reduced the cost very quickly.
All right. Okay, and then I think we'll follow up later too. So I think there's a common question which is coming up around. I know we talked about application transforms and you talked about the scale, but also just to compare it in terms of the Red Hat's cluster application migration CAM tool. How does this differ, the approach and the capabilities you took with Kasten K10? And if you can add a little bit to that, and maybe James, you can add to that too after Michael gives his.
Okay, so the CAM tool was an option, but actually we were seeing, we were trying to target some broader objective. We wanted to build backup as a service inside our cluster. So we wanted to have all the RBAC things doing, if a team can manage himself its own backup, manage himself its own migration, backing up some volumes and not this one, restoring and recreating namespace. We really wanted to have this tool as a service for each team. And of course, it was not possible to let a team doing a backup of someone else's application. We are on a multi-tenant environment. And the CAM tool was not designed for that. The CAM tool is designed for migration and disaster recovery. And we wanted something with broader objective, like mainly backup as a service. So CAM tool was an option, but we thought that then this migration was an opportunity to battle-proof the Kasten product for us. So we choose to do that with Kasten.
Yeah, I think Michael, said it perfectly. It's basically, if you have a broader objective around data protection and you need policy and you need transformations, the Kasten K10 platform provides those. The cluster application migration tool, which is supported by Red Hat and in the operator hub, is really meant to help you move applications from one cluster, Kubernetes cluster, to another, but doesn't take into account all those advanced features that the K10 platform has.
Right. Okay. No, thanks. That adds color. So depending on the application, the scale, and what you really need as a user, whether backup and data protection is needed even before or after the fact, those are the considerations one should keep in mind. All right. So I think maybe with that, the other question I had sort of related was, I think Tom, maybe you can add to this, which says something like, can you talk about the other use cases you mentioned, like backup, and how did sort of K10 switch into that? And there are a couple more, which I think so. Maybe Tom, since the thrust of this talk was obviously migration, we talked about it, but also given that there was a need to do backup as a service, maybe if you can talk about that in the context of Kasten K10.
Yeah, definitely. I think that the data mobility and migration use case tends to be more complicated, because whenever you're transferring between different environments, there's always many complexities you have to deal with. Michael went through many of these, but often API objects are not compatible. Maybe there's differences in the underlying storage that you have to account for how to provision it. And so I really think if you're able to support data mobility, then you kind of have the ability to take backups and restore your applications within a cluster with ease, basically. And I think that the real tenet here is that we focus on backing up things as an individual application at a time, and then from there you can compose whatever you need on top of that. And so in this case, if you're able to back up your applications and do whatever transformation is required to pull into a new environment, then of course you can also do your traditional backup recovery within the same type of environments. So.
Got it. All right, so I think maybe along those same lines, there's a question around sort of automation. I think it was around the time when you were showing the slide, Michael, about how you had both the import-export policies, and you also talked about needing to do this in a short amount of time with a large number of applications and I guess multiple moving parts. So I think the question really broadly is, can you explain a little bit about what are the things that you were able to automate and things which maybe didn't come in terms of automation?
You mean things that I was able to automate and things that I couldn't automate really? That's
yeah, I think the thrust maybe more is, and I'm trying to expand on the question. I think the thrust more in terms of what did automation mean for you in this context?
Right. Okay. So the thing is, when we first start to use Kasten, we use it in a nominal use case, which is go in the UI, choose a label for targeting different application, and just launch the backup and export, and then redo that to import the application inside the destination cluster. But it turns out that it's actually a lot of click, too much click. And automating was something that we really need to do. But to answer to your question, what was the things that we were not able to automate? Actually, we were able to automate everything. That's the thing, yes. From the backup to the export and the import, the restoration, the operation we proceed on the different applications, all that was completely automated. Actually, sometimes it took times, but we found ourselves able to not just do any manual operation, just launch a script, and it does all the job.
Yeah,
from the export to the import. Yes.
Thank you. I think with 2 people, yeah, I think you did. And I think with 2 people from the ops side supporting 700 active developers, I do agree that automation was a must-have here. So, all right, thank you. I think maybe in a related note, and I think Tom, you might also be able to expand on it. I think there was a reference to CRD while you were talking about one of the slides, and the question was, what is CRD, and maybe in context of the slides that you were showing, if you can add a little bit to that. So Michael, you want to just say that, and Tom, if you want to add.
I think Tom is the most qualified for that. Yeah.
Sure, happy to. So CRD stands for Custom Resource Definition, and it's kind of the most common and simple to use mechanism for extending the Kubernetes API. So all the APIs that, for example, Kasten and OpenShift use are really just extensions of this core Kubernetes API. And in fact, you yourself can create these objects pretty easily. And we chose to use these extensions because we really wanted to integrate with all the tools that the ecosystem has provided, right? So you can easily do an OC create backup, and then K10 will go and respond to that, and then take it back with your applications. And so in the context of these pipelines, it was really important because you could define all of these API objects in advance, and then you essentially just need to invoke them to run stages of your pipeline, right? And when Michael said this is all automatable, is because we simply just defined the set of API objects, and then we were able to apply them kind of directly using OC and kubectl, for example.
Right. And Tom, while I have you, I think there's another related question, which was from a few different folks, which is while obviously this particular instance we talked about, using OpenShift and AWS as the underlying infrastructure, are there other platforms, both from a infrastructure Kubernetes perspective as well as storage, that Kasten K10 supports?
Absolutely, yeah. I mean, we support a lot of the big cloud providers. We have kind of first-class integrations there. What I will say is that we're simply a product you install inside your Kubernetes or OpenShift cluster. And so really anywhere you can run Kubernetes or OpenShift, you can install us. We're, for example, OpenShift container certified, we're Kubernetes certified. And so we're really platform and kind of infrastructure independent. So there's no restriction there.
I think, Michael, this one might be for you, which is, I think you mentioned that you use both Rookceph as well as AWS EBS. So maybe if you can add a little more color in terms of when did you decide to use what, and if you used any databases also in your environment.
Okay. So when you work with EBS, actually you are EBS are great because they are crash consistent, they are quite easy to deploy inside the AWS platform. But if you work like we do with a high availability cluster, you are spending your cluster on free availability zone. And with EBS, you can just work one EBS inside one availability zone. And that could be an issue sometimes. Let's imagine that you use a pod, which is mounted with two EBS. If the two EBS were created on two different availability zones, then you can't mount the pod. That's just not possible. Besides, Ceph is bringing the ability to create some much smaller volume. When you are working with EBS, the minimum is 1 gigabyte. But when you are using Safe, you can work with a megabyte. It's not a problem. And most of the time for the development, megabyte is fine. So you don't have to spend 1 gigabyte every time. And another aspect, of course, of Safe is the security of your data, because there is a triple replication of your data with Safe. And that makes your data much more resilient when instead of EBS. If you're using EBS, you have to rely on over Safe mechanism. So for all these reasons, Safe was a good solution for us.
Got it. Okay, no, I think that's great. I know we are out of time, but maybe I'll take a couple more and if people still have some straggling questions, please type them in. And I think maybe Singh, I'll hand it over to you in a minute. But I think there is a question around, I guess maybe both Tom, you and James can talk about this. I mean, of course, we work closely together. As far as what was, I think the question was related to the CAM tool, what's the relationship between Red Hat and Kasten? I think maybe I can just quickly comment on that, you know, we work with the OpenShift container certification, and we work very closely, as you can see from this webinar. So maybe happy to follow up, and I'm sure James, I'll send those questions your way too. I think there is a question in terms of, Michael, just for the advantage of hindsight, anything that you might have done differently or any advice that you might have for people who are looking to do something similar?
Yes, one thing that I think is very important, two things actually. The first, don't try to implement your backup strategy yourself. It's because it's actually hard. It doesn't look that hard, but actually it's hard and it's complicated. First, you just make a backup and you're fine, and then you found out that you need to manage the retention, you need to manage many aspects, and it becomes very complicated. And so my first advice is just don't try to do it yourself unless you want to build a product. And the second thing I would do, if I had to change something on this migration, was maybe the way we manage the migration of the image themselves. I think we should have worked on the migration of the image in another way, like taking the image from a repository to another one, and to invest in this effort to do that properly. That would be the things that I would do differently. Otherwise, I think it was optimal from my point of view.
All right.
So Michael, you're not saying you would just use rsync for your backup and migration?
No, but we did it. We did a port forward, and we did many things. We did the rsync thing, but it doesn't work all the time. It's hard to manage.
It's great.
It's hard to manage.
All right. I think there may be some more detailed questions. Maybe I'll squeeze one more in. I think, Tom, this might be your way, which is essentially, what does the all resources filter mean? I think was one of the screenshots of K10, and what can you sort of filter versus not when you're capturing resources?
Yeah, so as I mentioned earlier, Kasten K10 has a deep integration with the APIs exposed by OpenShift and by Kubernetes. And really all the objects, all the API objects you see in a backup are represented by a name, potentially a namespace for project, as well as a grouping and a version. And what we've done with filters is we give you the ability to filter out exactly the things that you need to filter. So Michael gave some great examples of filtering out objects that don't make sense in your new backup. If you want to filter out some types of secrets, for example, you have that ability. And what we've noticed is that, for example, if I just take a raw if I slurp up all the objects inside a namespace, it really doesn't give you a backup that you can restore in many cases. And especially in this migration use case, where if you're using different versions of clusters, then objects from one cluster may not be available or make sense in the other cluster. And so I think for both security reasons as well as kind of compatibility reasons, we've enabled this feature. And you can do it you can do it kind of at any stage of your pipeline. So you can do it when taking a backup, or something we recommend is that you back up as much as possible, and then depending on what your target is, filtering on the target side.
All right, and I think the only plug I'll put in is you can just go to Kasten.io and press the try button and do this yourself. So I think, I know we are 5 minutes over. I think, Singh, I'm gonna hand it over back to you, just to be respectful of everybody's time here, and see if there are any last comments.
Very good, thank you. So firstly, thank you, Michael, James, Tom, and Gaurav for the session. It was very interesting and answering all the questions. I'm sure the attendees got a lot out of that. And secondly, thank you to all the attendees for spending the time on the webinar. If not all of your questions are answered, then please do reach out to us at info@kasten.io. We'll be more than happy to see how we can help you resolve those. And we will be following up with an email after the event with a link to the recording if you want to review something or share with your colleagues. Thanks a lot. Bye-bye.